My name is Christopher Jaggarnath, and I'm currently attending Will Crothers Secondary School, and this is my Grade 12 Calculus and Vectors CCT. The question I have for my CCT is from the McGraw-Hill Ryerson Calculus and Vectors textbook. The question states, consider a car shock absorber modeled by the equation h of t equals e to the power of negative 0.5 t sine t, where h of t represents the vertical displacement in meters as a function of time, t, in seconds. Determine when the maximum vertical and in meters per second occurs at its given value that v of t equals h prime of t. From the question we can determine that is a sinusoidal function, an example of dampened harmonic motion, since we're dealing with a car shock absorber. As shown on your screen, a dampened harmonic motion is when the amplitude of a harmonic oscillator diminishes over time due to friction. Also from the question, we can determine some very key pieces of information, such as the equation itself, h of t equals e to the power of negative 0.5 sine t, and the question itself to determine when the maximum vertical velocity in meters per second occurs and its value. In order to solve the question, we have a plan. First, solve for the derivative of h of t. Secondly, set h prime of t equal to 0. This is when the maximum velocity will occur. Thirdly, solve for t, which is in meters per second, in other words, the velocity. Fourth, we could check our answer using a graphing calculator. And fifth, providing a therefore statement to answer the question. First, we must solve for the derivative, h prime of t. In order to do so, we can use the product rule to differentiate the function. The product rule states f prime g plus g prime f will give you h prime of t. In the original equation, we can determine that there are two other equations within the equation, which is why we can use the product rule to differentiate the function. One of the functions, highlighted in blue, e to the negative 0.5 t, and the other equation, highlighted in green, sine of t. In order for the product rule to work, we must find the derivative of f of x and the derivative of g of x. The derivative of f of x, we must multiply negative 0.5 by the equation e to the power of negative 0.5 t. Once you do that, you'll be left with negative 1/2 e to the negative 0.5 t, which is the derivative of f of x. Now to determine the derivative of g of x, which is quite simple. The derivative of g of x, which is sine t, is just simply cos t. Now that we have set up our product rule, we can expand our equation. Once we expand, we can see that we have a common factor, negative 1/2 e to the negative 0.5 t, highlighted in yellow. We could then take this out of our equation and simplify it even further, as shown in the second line. Now once we have a fully simplified our equation, we can set it equal to 0. We can set one of the factors equal to 0. As shown, we have set negative 1/2 e to the negative 0.5 t equal to 0. In this case, it'll have no solutions, because you cannot have a 0 in the numerator of an equation. That would be an error. Just to re-emphasize, the reason why we set the equation equal to 0 is because this is when the maximum velocity will occur. Now we can set the other factor equal to 0. In blue, we can see sine t minus 2 cos t. Now we can solve for the variable t. Just as a reminder, sine t over cos t equals tan t. Once we solve for t, this will be the max velocity that the car shock absorber would experience. Now to ensure that we're correct, we could put our equation into decimals. As shown in the graph, you can see that the maximum velocity occurs at t equals 0 seconds, and that the max velocity is indeed 1 meters per second. Now to conclude our question, we must write the final therefore statement. The maximum velocity occurs at t equals 0 seconds, and the maximum velocity is at v equals 1.1 meters per second. A career where this could be useful in is that of an automotive technician. An automotive technician will have to ensure that the car's shock absorbers are working effectively. So when cars go over speed humps or humps in the road, that they'll be able to steady themselves effectively. This concludes my grade 12 Calculus and Vector CCT. Thank you for watching.